Alright, welcome to the first video of the new module dealing with factoring. As some of you are aware, the last module I talked about that Mr. Finger was not going to be with us anymore. I did not explain to you that Mr. Finger met with an unfortunate accident. Some of you know all the details on it, others of you don't. But the moment is silent for Mr. Finger. Alright, good enough. Okay, so anyway, going on with this situation, we're dealing with factoring. But before we get into factoring, let's kind of understand the opposite of factoring. Factoring is when we're breaking apart. So first, in order to learn how to break something apart, we first need to know how it gets put together. Alright, so one of the first things that you already kind of know is what we call monomials. Very simple ones like 3, that's a monomial, it's just a number by itself. Another simple one would be like 4x. Okay, so these are very simple monomials. And we also know how to multiply monomials. We've already talked about that in I think back in module 1. We just didn't give them terms, such as if I wanted to multiply 3x and 6y, I'm going to multiply these together. We know that we're going to multiply the numbers, which are what we call the coefficients. So 3 times 6 is 18. And then we're going to multiply our variables. Since these variables are different, we're just going to simply say xy. Okay? So 3x times 6y is equal to 18xy. Very simple. And this is a monomial times a monomial. However, that's not what we want to do. We want to multiply binomials. So a good example of a binomial is this. Alright, this is a binomial, meaning that it has two parts. We have this piece right here, which is just x. Remember, if there's just a variable, really what's in front of it is a coefficient of 1. We don't normally write that, but it's accepted. Alright, so get rid of that. So this is a binomial, x plus 5. And another example of a binomial might be x minus 6. These are two binomials, and what we want to do is multiply them. Okay? So there's several different ways of this. I can actually take both of these terms and multiply it by x, then multiply these same two terms by -6. And which is essentially what I'm getting ready to do. And I can multiply it using that's really what we call distributive property. But another thing that is more commonly known, and you probably know this from grade school, is the FOIL method, where it is the first, the outer, the inner, and the last. That's how we multiply. So, what do I mean by first? When I multiply by the first, I'm multiplying by the first terms of each binomial. So I'm going to multiply by the first, and I'm going to put f there. So x times x gives me x squared. Alright? Now I want to multiply by the outer. So I'm going to multiply by the outer pieces. Basically what's on this end and what's on this end. So I'll put an O there. Alright, so my outer, x times -6 gives me minus 6x. Now it tells me to multiply by my inner, which is these two guys. My inner two pieces, 5 and x. Well, 5 times x is plus 5x. My last piece, no pun intended, is to multiply by the last. Alright? Which is going to be these two guys, the 5 and the -6. Well, 5 times -6 gives me -30. Alright? So, now that we've got all this done, we're going to make sure all our terms that are, all our like terms are combined. There's nothing to combine with x squared, so we just write it down. But minus 6x and plus 5x, they can be combined, and we can just get -x. And then there's nothing to go with the -30, so we just put -30. So, my original problem, x plus 5 times x minus 6 is equal to x squared minus x minus 30. This is how the basic FOIL method is done. So I'm going to do one more with you, and I'm going to leave the other two on your own. In this problem, we're taking 5x plus 3, we're going to multiply it by 3x minus 5. We're going to use the FOIL method again. This time I'm just not going to draw out all the little lines. Okay? So first, we'll multiply the first terms. 5x times 3x gives me 15x squared. Alright, then I'm going to do the outer, so it's going to be 5x times a -5, which gives me minus 25x. Now I'm going to do my inner, which is this 3 and this 3x. So 3 times 3x gives me plus 9x. Now I'm going to do my last, which is 3 times negative 5 gives me negative 15. Now combine all my like terms, I get 15x squared. Well, minus 25x plus 9x, that's going to give me minus 16x. Double check. Yes, minus 16x. And then lastly, since there's nothing for me to combine the minus 15 with, I'm just going to write down minus 15. So 5x plus 3 times 3x minus 5 gives you 15x squared minus 16x minus 15. Alright, so at this point in time, I want you to pause the video, try the next two on your own, and come back and see what you did. In the first problem I asked you to do, it was 10b minus r times 6b plus 3r. I'm not going to do the whole FOIL method with you. I'm just going to show you what you should have got. The first part after your FOIL, you should have had 60b squared plus 30br minus 6br minus 3r squared. Combine the like terms that you found in the middle. Ultimately, your final answer should have been 60b squared plus 24br minus 3r squared. And that would have been everything here. The next one, we have a plus b times a plus b. And we get a squared plus ab plus b squared. Simplify all that, combining like terms, a squared plus 2ab plus b squared. Now this bottom guy that you see right here is actually very important. After who knows how many thousands, if not millennia of years, where people have been, and that's an exaggeration, thousands of years is more accurate, where people have been doing this type of math, we found some interesting, and I say we as a human species, we found some interesting things, and what they are patterns, I should say, and what we call those are special products. And so if you look in your notes, and I've kind of given you a hint to what those special products are. These are some very basic rules. Like in this first one, it says a plus b squared. Well, if you just remember what we just did, a plus b squared is really saying a plus b times a plus b. Well, that was what we just did. However, when we do this, a plus b squared, we always get this format. We get a squared plus 2ab plus b squared. Alright, we always get this format. And this is what we call square of sums. So make sure that this is written in your notes, okay? A plus b all squared is always equal to a squared plus 2ab plus b squared. The next one is called square of difference, where instead of adding, I'm subtracting. And what this gives me is a squared minus 2ab plus b squared. Notice the difference between them, where this one has on the second term an addition, this one has a subtraction. Alright? And no matter what way I get it, if I'm always squaring a difference like I am now, I will always come out to be in this format. The last one is probably the most useful to you, because you'll see, you've got to really pay attention to it. Matter of fact, all of them are useful, but this one's the one that should, when you see it, bells should be ringing off when you see it later on. It's called difference of squares. This is a favorite in the math community. Matter of fact, just about every piece of homework I have ever done in algebra and everything, difference of squares will always pop up, and you've got to know it. Alright, so if you want to make a big star on it, this is the one that you need to have memorized. These other two you can kind of figure out later on using what we call factor grouping, but I'm not going to talk about that yet. So, but this is a big one. Alright, so a plus b times a minus b is equal to a squared minus b squared. Alright, when you see a plus b, whatever those numbers or variables might be, being multiplied by those same things, but they're, instead of adding this time, they're subtraction. So notice that the signs are different between the two. You're going to come up with a squared minus b squared. Now, how is this even useful in knowing all of this? Well, it makes things a whole lot easier, especially like when we can FOIL everything. Anytime I give you a binomial, you can FOIL it and you always get the right answer, as long as you know what you're doing. However, there's some special cases where there's no reason to FOIL when we can just follow this format. So let's do some examples. Alright, so what we're going to do is we're actually going to try to use those special product rules to help us out in solving this. I could FOIL this problem, x plus 3 times x plus 3, FOIL it and I get the answer. But if I know those special product rules in the top of my head, I don't have to FOIL. I could just kind of use this as a cheat. So let's kind of look at this. I know that this, because I'm adding and it's being squared, is what we call square of a sum. Alright, so I can really just write this up top just so we can see a comparison. Alright, according to square of the sum, it's going to be a squared plus 2ab plus b squared. What is this telling me to do? It's telling me that the first term, which is a, to just simply square it here. So I'm going to take this first term and I'm going to square it, and I'm going to say, hey, that's equal to x squared. The next thing it's telling me to do is to multiply a and b and 2 all together. So I'm going to say a times b gives me 3x, times 2, according to this, is going to give me 6x. The last thing it tells me to do is to square the b. In this case, it's the 3. So 3 squared is equal to 9. So x plus 3 squared is equal to x squared plus 6x plus 9. And we did this without having to do FOIL method. Now after a while, especially when you memorize this, it won't take nearly as long as what it just comes naturally. Oh, done, 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 done. The more you do it, the faster you get. Alright, so let's try a different one. We'll just go on down the line here. Let's say 3x plus 4 squared. Alright, so I'm going to do this faster. I'm going to take the first term and I'm going to square it. So that's going to give me 9x squared. I'm going to take the first and the second term and I'm going to multiply them. That gives me 12x. Then I'm going to multiply it by 2 according to this equation, and that's going to give me plus 24x. The last thing I'm going to do is square the last term. Well, 4 squared gives me plus 16. I am done. Alright, so for this next one, it's very similar to square of sums, and it's the difference between it is that I've got a subtraction here and I have a subtraction sign here, but everything pretty much remains the same. So our very first problem that I've given you is x minus 6 squared. So we're going to do just like we did with square of sum. Alright, so we're going to do the exact same thing again. I'm going to substitute in. Well, a squared is going to become x squared because that's what that's telling me to do. So x squared minus, I'm going to write this out just so we can see it, minus 2, and this tells me to take a and b. Alright, well, a is going to be x, and b, your instinct might be that b is negative 6. Not in this case, you just want the number. In this case, it's just 6. So it's going to be 6 times x gives me 6x. Multiply that by the 2, and what do we get? Minus 12x. Now, why is it a minus here? Well, because that's a minus there. Okay? It has to be in this format. Alright? So x squared minus 12x. And the last thing tells me to square b. Well, what's b? 6. So it's going to be plus 36. We're done. Alright, the next one, let's try one more. Let's try this one now. This one says 3x minus 2 squared. So, does anything change? No. We're going to take the first term, which is 3x. We're going to square it, and we get 9x squared. We're going to take the two terms, and we're going to multiply them. 3x times 2 is going to give me 6x. Multiply it by that 2, I get 12x. So it's going to get me minus 12x, and then last it tells me to square the final term, which in this case is 2, so we square it, we get plus 4. Easy peasy, lemon squeezy. Alright, so this last special product rule is what we call difference of squares. Don't confuse that with the square of difference. Quite frankly, you have those terms that says square of sum and square of difference. I don't really like those terms because they just get confusing. It's easier just to memorize the rule. But this rule right here, everybody agrees that this is what we call difference of squares. Okay? The other two rules that we covered before, their names can change in different types of company that you're with. Why? I don't know. Math is weird that way. Going on this thing, I'm going to do x minus 5 and x plus 5. Let me show you how simple this is. Look, the a and the b are the same thing in both binomials. The only difference is the signs. Alright, well that's cool. So all we have to do is, according to this, square my a minus a squared b. So what's that going to be? Well, a squared a is x squared minus, what's b squared going to be? Well, in this case it's going to be 5 squared, 25. Bam, you're done. That's it. So the next one, you have 3x plus 3 and times 3x minus 3. Well, same thing. Square your a's. 9x squared minus square your b's. 9. You're done. That's all this is. So you have 3 remaining on yours. So try those 3 out. Pause the video. Come back and see how you did. So these last 3, I was a little bit of a jerk. I just gave you all variables, no numbers or anything like that, and it's just a little bit odd. I made it a little bit harder on you because I'm a jerk that way. But the procedure remains the same. You know the different things. You have square of sum, which is this. We have square of sum. This is my a term. So my a term gets squared, which becomes x squared y squared. This is then multiplied together. X times y times z is xyz. Multiply that by 2, 2xyz. And then the last piece is to take the b term, which is z, square it, you get z squared. Alright, same thing. We now have square of difference. So, what's my a term? xy. Square it, x squared, y squared. My a term and my b term get multiplied. That gives me xyz. Multiply it by 2. I get minus 2xyz. Square my last term, z squared. The best one of them all, difference of squares. All I'm going to do are square my a term, which in this case is xy again, gives me x squared y squared. Then square my z term, my b term, which is z, and I get z squared. So x squared minus y, x squared y squared minus z squared. All right. So hopefully you did okay on that. And now I will tell you this: these 3 special product rules, memorize them. Okay, again, this is one of those things that you need to know, especially if you're going into more algebra later on after this. These terms are going to help you so much. And I will go ahead and tell you, you will not have this on test day. So I expect you to know these, especially this guy, difference of squares. This is the one I expect you to know more than anything, because later on we can actually break this down using some other key stuff. But that's the big one. That's the big one I want you to know. Alright, so let's go on to the next part. In these next few questions, I'm actually trying to get you to find products. I'm actually getting you to multiply monomials and binomials together, and you're going to end up coming out with a final answer. So when you look at this, excuse me, I would edit that out, but I'm too lazy, so I'm going to just cough in the video and keep on trucking. So, P times 6P plus 7 times 6P minus 7. Your instinct is probably telling you multiply this guy and this guy first. That's probably your instinct. And when you're done with that, to whatever you get here, multiply it by the last term. Well, here's the truth. You will get the correct answer that way, but it's going to take you too long. the first thing that you really need to do is look at the terms. Don't just start going, okay? Look at the terms first. Notice this term and this term are very, very similar. I have 6p plus 7 and 6p minus 7. Wait a minute, what's that remind me of? Difference of squares. So what I can do is, instead of trying to multiply it all out, I'm going to use difference of squares on these two right here. And so I'm going to get p. That's where I'm going to bring that down. We're going to do our difference of squares. That's going to give me 36p y, not p, excuse me, p squared. Why? Because 6p times 6p, or a squared, remember that little part in that little formula I gave you, gives me 36p squared. Now I'm going to take the b portion, which is the 7s, and I'm going to square it, and I'm going to get minus 49. Okay? I just made my life easier. Now multiply by p. 36p cubed minus 49p. If you can remember to look for those patterns of special products, your life is going to become so much easier. So let's try one more. Alright, so in this particular case, your instinct might be saying, hey, multiply right straight across. And in this case, you technically would be right, but for the wrong reasons. Why do we want to multiply these two first? Not because they're in order that way, but because of what reason? Difference of squares. Woo! Told you it was going to come back to haunt you. So, difference of squares. What do? We take the a term, we basically square it. So we get x squared. We take the b term, we square it again, we get minus 9. And now we've got a new equation. This guy gets brought down. Okay, I'm just going to draw an arrow because we haven't used it yet. Well, look at this. What's it look like? Oh, difference of squares. How about that? Sorry, I'm being condescending. My apologies. But we have x squared minus 9 times x squared plus 9. So again, it follows that same pattern of difference of squares. So what are we going to do? We're going to take the a term, which happens to be x squared. We're going to square it. Well, what's x squared? Squared x to the 4th. Then we're going to square our b term. Well, what's 9 squared? 81. So minus 81. Again, this looks long-winded, but if you can look for those special product rules, your life will become really, really simple. So your job now is to try your next two that are on your paper. I've got them up on the board. Pause the video. You know the drill. Blah, 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 blah. Again, like I told you a while ago, follow your procedures in looking for special products. So my special products here will give me 9p squared minus 1. Multiplied by your p, you should ultimately got 9p cubed minus p. Alright, next thing, same thing, difference of squares. This right here and this here are going to be multiplied to give you x squared minus 1. We bring down this guy because we haven't used it yet. And now we've noticed that these two terms now make a difference of squares. When we multiply that out like we're supposed to, we get x to the 4th minus 1. The next major thing that we want to talk about is called perfect cube formulas. Take your time. I'm going to go through it. I'll try to stay off screen so you can read this a little bit better. Let me see if I can adjust the lighting. It's just a little bit dark. That helps a little bit. Alright, so this first thing is telling me to take a minus b and cube it. In other words, it's telling me to go a minus b times a minus b times a minus b. That's what's happening here. Okay. Now I can work this all the way out, but I'm lazy and I don't want to. So we have another type of special product rule, and that gives me this guy. So what's happening here is it's telling me that whenever this occurs, I'm going to cube my first term, then I'm going to take 3 times the square of my first term times b, plus 3 times my first term times the second term square minus the second term cubed. Okay, we'll do this in some numbers. You'll see how this all works out in a minute. And then the bottom one says a plus b all cubed. Again, it could be saying a plus b times a plus b times a plus b, but when we work it out, we get a cubed plus 3a squared b plus 3ab squared plus b cubed. All right, so I'm going to give you a moment to finish kind of typing this out, whatnot. No, we'll go from there. I just realized I said typing, writing, doesn't matter, right? I'm weird, that's okay. So let's look at an actual problem with numbers and see how this little formula sets us up and helps us. Alright, so the very first one I gave you was x minus 2 cubed. Alright, so what it's telling me to do is take the first term that I have, which is a, and cube it. So this is going to be x cubed. Alright, now what I'm going to do now is take my first term in this one, cube it, which is going to be give me x squared. Alright, so I'm just write that down for now just so I don't forget it. And then it's telling me to multiply it by the b term, which in this case is 2. So that gives me 2x squared. But I'm not done. I need to multiply it by that negative 3. So ultimately I get minus 6x squared. Alright, so do that one more time with you just to make sure you're up with me. We are going to take the first term, square it, that gives me x squared. Multiply that by the second term, which is 2, that gives me 2x squared. Multiply it by the negative 3, I get minus 6x squared. Now let's do the next one. Alright, a is just going to be x, so I'm going to write that down just so I can keep in track in my mind. Then it's telling me to square the second term. Well, 2 squared is 4, and when I multiply that, I get 4x. But it's also telling me to multiply it by that 3, so 4x times 3 gives me plus 12x. Alright? Now, the last one just simply says minus the last term cubed. So my last term is 2. Well, 2 cubed is 2 times, let's do it. 2 times 2, that's 4. Multiplied by 2 again to make it cubed, I get 8. So it's going to be minus 8. Alright, same principle down with this one. This time I've got to do 5 plus x cubed. Alright, so we'll follow the same procedure using this guy. What am I going to do? My first term gets cubed. 5 times 5 is 25, times 5 again gives me 125. Now, it's telling me to square my first term. Well, that's going to give me 25. Multiply that by my last term, that gives me 25x. Multiply that by 3, I get 75x. Next one. I keep my first term, so it's just 5. Multiply it by my second term square. Well, my second term is x, so x squared is x squared times 5. That gives me 5x squared. Multiply that by 3, I get 15x squared. And then lastly, cube my final term, which in this case is just going to be x cubed. This one does get confusing, I will admit, so you do need a little practice. The good thing is there's not a lot of these on your homework, so as per usual, pause the video, try the next two on your own, and come back and see how you did. Let's check how you did. For just kind of teaching purposes, I left this top piece up there just so you can kind of see how things are still working. So ultimately, you would need to remember that you're going to cube the first term, which would have got you x cubed. Then you're going to go 3 times a squared b, which is basically saying 3 times the square of the first term times b. You should have got minus 9x squared. Then you got 3ab squared, which would have got you 27x. And then lastly, you would get minus 27. So it's going to be x cubed minus 9x squared plus 27x minus 27. That looks, there we go. All right. Now, same thing. I'm not going to walk all through this, but you should have got 216 plus 108x plus 18x squared plus x cubed. All right. So we have two more special products that's dealing with perfect cubes. Again, you probably won't see many of these in your homework. I believe I said that with the last set of perfect cubes that we just discussed, but you shouldn't see many of those. but be aware that they do exist. And they can get slightly confusing if you're not careful. So if you happen to come across this basic format where we have a plus b and it's being multiplied by a squared minus ab minus b squared, when you multiply it, you're going to end up just getting a cubed plus b cubed. And it's the same concept with this. If you see this type of format, you're going to end up getting a cubed minus b cubed. Let's be honest. You're not going to see a lot of this, but what you will see is this, and you're being told to factor it. And so what you will do is basically you'll use this format, what you see right here, and you're going to go from here all the way back to here. And I think it's in the last video we're going to talk about that particular thing a little bit more, because like I said, you won't see it very much in this set of homeworks, and if you do, let me know and I'll correct that statement. But you'll see this more off in the last set of homeworks. But just to kind of let you be seeing, and I've given you two problems and I'm going to let you look at it. But if you notice, it's pretty straightforward. Your very first one is x plus 3, okay? Well, x is being your a, and the 3 being your b. Well, if you look at that and you compare that whole expression compared to this expression, you'll notice that, well, x is being squared just like this a is. You notice that the 3 and the x are being multiplied just like this AB are. And then you'll notice that your 3 is being squared just like this b is. Well, if you can see that, you should be able to automatically say, hey, that's really just going to say x cubed plus 27. I mean, that's all it is. X cubed plus b cubed, which would be x cubed plus 3 cubed, which is 27. Same concept with the next one. We have x minus 2. Look at it. Does it follow this same type of format? Well, yes, it follows this one. So basically, we can just say, hey, that guy is really going to be x cubed minus 8. All right, so the big take from this is you may not see this in your homework directly, but you are going to see it later on in the last homework, and I'm going to give you a big heads up on that, because that's going to throw you for a loop if you're not prepared for it. Again, this doesn't happen often, but when it does, this is one of those good rules it's good to know and have in your back pocket when you need it. Alright, so now we're getting to the fun part. I just basically taught you how to put things together, okay? How you multiply things together and blah, blah, blah. And if you can understand how things multiplied and how we get to a certain point, you can work backwards from that place. And so what we really call that is factoring. In other words, we're just going to find out what two things, when multiplied together, equals some number, okay? And you're kind of used to factoring already. You probably got taught this in grade school. Let's keep a very simple thing. Let's say you have the number 6, and you were asked, well, what are the factors of 6? Well, what it's asking you is, what are the possible things you can multiply to make 6? And you were probably told prime factorization tree, okay? And that's really what you're doing, is that what are your prime factors? Well, remember, prime factors are numbers that can't be are only divisible by 1. You need to. My son's in here needing a diaper. All right, we'll come back. All right, so now that I've changed my son's diaper, hey, that's what happens, guys. All right, what we were talking about was prime factorization. You probably, again, remember this from grade school, where you're told to break this up into prime numbers. And remember, prime numbers are basically only divisible by itself in the number 1. All right, so we can break this up pretty easy to 2 and 3. So these are its prime factors. I can't break 2 up anymore. I cannot break 3 up anymore. So we factor this. And what we're actually going to do is very similar in this regard, but people get confused on this. So let's do something really simple. Let's say, here we go, x squared minus 4. All right, and your job is to factor this. A lot of people start doing this. Well, that's x, and this is 2, and this is 2, and then that's what they give me, but that's not what I'm looking for. What I'm asking you is, what binomials, when multiplied by them together, will give me this? Well, I'm going to give you the answer for it. I know that what I can actually factor this out to is this: x minus 2 and x plus 2. Notice that they look similar in concept, that I'm breaking this down to its prime numbers. This one I'm breaking down to its, if we wanted to give it a terminology, its prime binomials. Okay? That's what's happening in here, or actually we could say prime polynomials. Well, that would be a better statement. And so that's really what we're doing. So if you're taking a number 4 and you're trying to give me a factor tree, it's not going to work. It will not work. And so that's what we're getting ready to teach you right now, is how to really factor a polynomial. And I've already kind of given you hints on this, and the first thing that we do is actually listed in your notes. It says we're going to factor out the GCF. Well, GCF means greatest common factor. When I say that, well, let's go ahead and cut to the next clip and I'll explain to you what greatest common factor is. Now, what I asked you to do in the last clip is we're going to try to factor out what's called the greatest common factor. Factoring and division are very similar, and so you may have been told this, that you want to find the biggest number you can divide both terms by. Well, that's not what we're really doing. We're not dividing here. We're actually trying to break it apart into its individual pieces. Though the process of division and factoring are very closely knit, they are not the same process. When you divide by something, whatever you're dividing by disappears, but when you're factoring by something, whatever you factored by, it stays there. Let me show you what I mean. Alright, so what we're going to try to do in this one, this is the very first one, is I need to find the greatest common factor that is in both of these. What number can I factor out? So let's look at these two. Now we have a 6 and a 2. Alright, so we need to find something that they have in common. This is where your factor trees actually can help you a little bit. Alright, so what do you notice about the 6? Well, its prime factors are 2 and 3. Okay, what are the prime factors of 2? Well, the prime factors of that are just 2 and 1. So what do we have in common between these two coefficients? Well, the number 2. So I'm going to write the number 2 down. Now let's look at the next thing, is our variables. I have an x squared and I have an x. Well, what do they have in common? Well, I can factor out an x for each one. So I'm going to write x down. So what did I just say? It means that I can factor this first term by 2x. And your instinct's like, well, I want to say 6x squared divided by 2x. And yeah, you're kind of in the right mentality, but you're not dividing, you're factoring out. So this is really what I need you to ask yourself. What numbers, or number, whatever, times 2x will give me 6x squared? Well, what you should be figuring out is that's going to be 3x. Alright? The next thing is that since we know that this is our greatest common factor for both terms, we're going to factor out the 2x out of this guy. Well, when I do, you should be thinking, hey, you might be thinking 2x divided by 2x is 1, and you're right, but that's not factoring. We're still got to keep this guy. This guy has not disappeared. It's still there. We factored him out. We just didn't take in it. We do that kind of like through division, but we're not really dividing. It sounds really weird, but that's the way I need you to understand it. We're factoring them out, not dividing. Big difference in terminology. So what do we get? Minus 1. So what I've done is I've taken this and I've broken it apart by finding the greatest common factor. So what was my greatest common factor again? In this case it was 2x. I factored it out. Now, how do we know this to be the case? Are we right? Are we good? Well, what we can do is remultiply to double check. And that's something that you're going to see me doing a lot, is multiplying. Okay? So, 2x times 3x, well, what's that give me? It gives me 6x squared. 2x minus 1 multiplied together, what does that give me? Minus 2x. So does my factorization work? Yes, it does. Alright, so again, big take. Factoring is not division. If this was division, guess what would have happened? This 2x would have gone away. But we don't want it to. We need that 2x. So we had to keep it there. That's the difference between factoring and dividing. Dividing, your divisor. Factoring, you keep both terms or multiple terms depending on what the situation is. So let's try another one and let's see what we do. Alright, so let's try this one. Same principle. What I want to do is factor out the GCF. Alright, so when I do this, I need to look at my coefficients first. That's the first thing I want to look at. Can I factor out a number from both of these coefficients? Well, the answer is yes. The one we can factor out, that's the greatest common factor, happens to be 3. So I'm going to write 3 down, just so I know it. What else can I factor? Well, now I have to look at the variables. There's an x squared here and there's an x here. So what's that telling me? I can factor out an x. So I'm going to do that. So now that I know that this is my greatest common factor, I need to start asking myself, 3x times what is going to give me 12x squared? Well, you might be thinking division again, and that's fine as long as you remember you're not getting rid of things. So you should be able to say, oh, that's 4x. How do you know that? Well, 3x times 4x gives us 12x squared. Well, now we need to factor out this guy using this guy. So when we factor out the 3x out of this guy, we get minus 3. So we factored out the greatest common factor, which is 3x, and we need to verify this. Well, let's double check it. 3x times 4x, what's it give us? 12x squared. 3x times negative 3, what's it give us? Negative 9x. In this problem, we have 35a squared b minus 30ab minus 15a. All right. Now, every time I am telling you to factor something, there's a set of things that I want you to do. I've already talked about it just a little bit. The first thing that you need to do, we've already talked about, is factor out the GCF, the greatest common factor. Okay, so that needs to be your number one, GCF, greatest common factor. Alright, so that's our first step that we want to do. So let's look at each individual term and find out what our greatest common factor is. So first off, we start with the coefficients. We have a 35, we have a 30, and we have a 15. So what numbers can we factor out of it? Well, this one right here, our prime factors will be 5 and 7. Well, what about this? Could we factor out a 7 with this? No. But we can factor out a 5. What about this guy? We can factor out a 5 here. So what we've just discovered, out of those coefficients, our greatest common factor just for the coefficients is 5. So I'm going to write that down because I don't want to forget it. Now we need to look at each individual variable. This one I have a squared. I have an a here, and I have an a here. Well, what's that telling me? It means that I can get rid of an a. Since each term has an a, I can get rid of an a, and I can factor it out. So how many a's can I get rid of? Well, since this one only has 1, and this one only has 1, I can only factor out 1a. So I'm going to put that there. Now let's look at b's. I have a b here, I have a b here, but I don't have a b here. So what does that tell me? It tells me that I can't factor out any b's. Why? Because all 3 of these have to have a b. Do all 3 do? No. So my greatest common factor in this particular expression is just 5a. So now we need to start asking ourselves, what number, or what monomial, or whatever you want to say, times 5a is going to give me 35a squared b. Well, we know 5 times 7 is 35, so I'm going to put down 7. We know that a times a is going to give me a squared, so we'll write down a. And we know that we're going to have a b there, so we're going to put b. 5a times 7ab, let's double check before we move on. Does it equal 35a squared plus b? Pause the video, coming back. Alright, so let's go back to it. He's decided he wants to teach with me right now. So a while ago we were factoring out the 5a. We wanted to find out, does this match that? When we multiplied it all together, yes it does. It does match that. So now we need to check out our second term. When we do, we can know that when we factor out a 5 out of that, that's going to give me a 6. We factor out the a, so that just goes, and what's left is a b. Now, does 5a times negative 6b give me this? Yes, it does. You thought that was funny, didn't you? Oh, don't slap Daddy. All right, now the last thing that we need to do is factor out 5a from this guy. Well, that's going to give me minus 3. And the a's factor out. So, what have I just done? I have factored out 5a from this entire expression, and I got this expression left. So, this is not, my answer is not 7a minus 6b minus 3, it's 5a times all of this. Why? Because this is not division, it is factoring. Make sure you understand that. Now, that was my first step, just factoring out the GCF. The next step says we are to check for special products. Well, what are those special products? Well, the special products are what we talked about earlier. The a plus b squared equals a squared plus 2ab plus b squared and all that stuff. We want to know, does this term right here follow one of those special product rules? Well, I'm going to help you out. This case it doesn't. Well, how do we know? Well, look at this. This term and this term should be sharing something in the middle. Well, the only thing that they're sharing is nothing. There's no a in this one. Where there's an a here, there should be an a here. Where there's should be a b here, there should be a b here. So it's got to all share. In other words, this does not follow your special product rule. As we move on, you're going to start seeing those that do, and you'll start understanding how this actually works out. So let's go ahead and cut to the next clip. We'll see if I can get him down for a nap, and we'll try to work on it. I don't know whether you noticed in the last clip where I had my son, his mouth was all blue, and he had blue, looked like he had bruises all over him. My wife took him outside and had some yogurt with blue food coloring, and he's kind of stained up. We were using it like paint. It's something he can play with. But anyway, I wanted y'all to, I didn't know if y'all happened to see that in the video. His mouth is all blue. He's got, the legs are all blue. Anyway, let's get on to the actual math. Alright, so we have this problem, 64 minus 81x squared. Alright, we got to factor it. Now, first things first, factor out GCF. Can we find anything? Well, is there a number that can go into both 64 and 81? That's the first thing that we need to ask ourselves. I'm going to go ahead and tell you, you can try, but it's not going to happen. Okay? There is no number that we can actually factor out of this guy. Alright, so what about the variables? Well, there's no variable here. So we cannot factor out anything. Alright, so we just did step one. That's as far as we could take it. The next step is saying check for special products. Alright, well, hold on. Is this a special product? Well, we need to start looking at it a couple different ways. First off, why do you notice this? It's a two-term. Alright, so are there any special products that have two terms with them? Yes, there are, and this might ring a bell. Remember this one? Remember this one right here, this special product, a minus b times a plus b equals a squared minus b. This is the only special product that I have shown you that has two terms in it that fit this. So, does this term and this term relate to one another? That's what you need to be asking yourself. So, what do you notice about this? Well, according to this, our special product, a squared, this first term right here should be a square. Well, is 64 a square number? Yes, it is. Guess what? So, wait a minute. That's telling us something. Okay, so that's a square. What about this term? Well, according to this, the second term should also be a square number. Well, is 81 a square number? Yes, it is. Is x squared a square number? Hey, yes it is. Oh, wait a minute, what's this telling us? If I know that this is a special product, and I can say that, wait a minute, the square root of 64 is 8. Uh-oh, now we're getting somewhere, okay? And we're going to use, matter of fact, I'll put it over here. We're going to put that as 8. And if 8 goes there, 8 also has to go over here. Cool, cool, cool. All right, now, what else do we know? This is 81x squared. Well, 81 we know to be the square root is 9. Hey, minus 9, plus 9. All right. What else is left? We have an x squared. Still following this rule, working backwards, and we can put x in there. So what did we just do? We just factored this guy to say 8 minus 9x times x plus 9x. Can I do anything else with this? No, I can't. This doesn't follow any special product rules, and there's no greatest common factor here. The same thing with this one. There's no greater common factor, and there's no special product rules that follow this line. So I have factored this as tiny as I possibly can. Alright? So, can we prove it? Is this what I just discovered? This guy right here. Hey, guess what? Special product rule. All right, 8 times 8, 64. 9x times 9x, 81x squared. And we got the subtraction. Bam, we're done. We just factored this thing. In this problem, you are asked to factor this, okay? There are several different ways of doing this. There's a long way and then there's a short way. And your first instinct is probably to do it the long way, and that's okay. So let's just kind of see where it gets us doing it the long way. And then we're actually not going to even complete the long way because you haven't learned how to finish it the long way. So let's do it just to kind of show you what your instinct might do. Your first thing is probably you want to just go ahead and solve this out because of order of operations. Well, you know this is a square or sum of squares. So you follow that rule, a squared plus 2ab plus b squared, which we showed you earlier in the video, and you find out that this guy is going to be y squared plus, well, what's 4 times y? That's 4y. Now double it because it's supposed to be plus 2ab, and we get plus 8y, and then we multiply the 4, square the 4, and that gives us 16 minus 64. And your job now is you're going to like, hey, I'm just going to go ahead and subtract this thing. And I get y squared plus 8y, and you're going to say minus 48. Alright, this is where you probably would get to doing it the long way. Now, here's the thing. We could take this farther, but you don't know how. I haven't taught that to you yet. Now, you might know how from grade school, that's fine, but I'm not going to show you just yet. So what just happened? We did things the hard way. Could we finish this out? Yes, we could. You might be thinking, well, how? Well, we'll show you in the next video. Not showing you now. So, what could we have done to make our life simple? Well, let's go back to the original problem. Alright. You need to think outside your box. How many terms do you see? Well, you're probably like, well, multiple terms. Think this through. This right here is a term by itself. Notice what's happening. This one term is being squared. Look at this term. Hey, wait a minute. That's a special type of number. What is it? It's a perfect square. So what's just happening here? Hey, bells should be ringing in your brain that, wait a minute, this is very familiar to, guess what? Difference of squares. Remember that guy? It's coming back to haunt us. It's very similar to this. Well, if A in this case happens to be y plus 4, I'm going to write it down. Y plus 4. That's going to be my A. So I'm going to put this, and I'm going to put this. Y plus 4. Alright, so that's my A for this little expression. Well, what's my B? Well, my B is right here. What's the square root of 64? It's 8. So I could say this to be plus 8, and I could say this to be minus 8. Hey, now I can do something else. I can simplify each one of these things, and I can say y plus 12. Let's make that look like my y a little bit better. I can say y plus 12 is times, what's this one going to be? Y minus 4. So what just happened here? I used the difference of squares on this one because this term, y plus 4, is my a. And this term, 64, we know to be a perfect square, happens to be my b. And when we do that, we can say, hey, a plus b and a minus b. Plug it in. And we ended up getting this to simplify. So the question that you now have to ask yourself is, how do we know that this and this equal that? Well, guess what you get to do? Multiply it. So let's find out. So our answer that we came up with when we factored this piece out to be y plus 12 and y minus 4. Okay? That's what we got. So let's factor, not factor, but let's multiply by using what method? FOIL. First, y squared, outer, minus 4y, inner, plus 12y, last, minus 48. Simplify, y squared plus 8y minus 48. Hey, that looks mighty familiar. Guess what? You remember when we, at the beginning of this problem, we worked it out the long way? Guess what you got? You got that answer. You remember that? So, does our factoring work for this problem? Yes, it does. I've left you about 3 problems left for you to try on your own. So factor these out completely to the best of your ability. You know the deal. Pause the video, come back and see how you did. In these problems, you were supposed to follow those same things. First, factor out any greatest common factor that you can, and then see if there's any special products. So, in the very first one, you could factor out 2a. That's as high as you can go. You end up getting 2a times 6ab minus 5b minus 4. You ask yourself, does this follow any of my special product rules? No, it doesn't. So, this is as far as you can take it. Okay? This particular one anyway, this is as far as you can take this particular one. Alright, the next one, this is a special product rule, which when we break down gives us 2 minus 9x times 2 plus 9x. Again, another special product rule where we can break it out to y minus 5 minus 6 because the y minus 5 is our a term and the 6 will become our b term from our b term times y minus 5 plus 6. When we simplify this, we should have got y minus 11 times y plus 1. Alright, that finishes this video. So in the next video, what we're going to actually do is we are going to be continuing more factoring fun, and we're going to be breaking these things even down even farther than what we're currently doing. So see you in the next video.